Can you read the objective for us, please?
No, I can't.
I can solve and graph absolute-value inequalities.
On 3, 1, 2, 3.
I can solve and graph absolute-value one-variable inequalities.
So we don't need a Bayer model since we're still on the same concept, one-variable inequalities. We know what they are. We don't need steps because we already know how to solve them, right? But today the context is that we're going to apply it to absolute values. So let's get started right away so that we have enough practice here. So simplify, isolate, plot, and check. Copy example 1A. 1A, it says, solve the inequality and graph the solutions. Now, we've done plenty of practice with absolute value equations. Now we're moving on to inequalities and see how this works. Okay, so copy it. I'll give you 30 seconds, and then I'll go over it. Writing utensils down. Look up to the screen, please. Pay attention, please. Here it goes. So, if this was an equation, we know that we need to isolate the absolute value. Is that correct? Is there anything outside the absolute value? No. So I draw my line down. So at this point, don't do anything, please. Just pay attention. Here it goes. I'll ask the question. What number is 2 steps away from 0? -2 and 2. And that's why we write our two equations. Remember we used to write 2 equations? And then we would write x minus 1, how many times? Twice, x minus 1. But the only difference now, look up please, is that now it's a what? Inequality. Well, check this out. Look what's going to happen. The 2 became a negative, so look what I'm going to do. This one is a positive, so I just write it the same. Talk it over with your neighbor and let them know why I did that, please. Okay, yes. All right, let's continue from there. Let's do this one together from till the end. Here we go. Let's solve for this one. +1 + 1. X is greater than or equal to 1. +1 + 1. Oh, my bad. -1. +1 + 1. This is x is less than or equal to 3. Let's graph that. Get a number line going. Zero. I'm going to sketch my dividing points first, -1 and 3. So I'm going to graph first the first part. Does it include the point on the solution set? Yes, because it got the equal sign. So I'm going to make a solid point. And it says x is greater than -1. What numbers are greater than -1? Everything to the right. Julian, say correctly, please. This one. Does it include the dividing point for 3? Yes, so it's a solid point. And x is less than 3. What numbers are less than 3? Everything to the left. And if you notice, they intersect here, so this is a what? And. Okay? Now, let me show you how to write the solution set given the graph. Writing utensils down, please. Check this out. Solution set of all x such that did you see that?
No.
Okay, here it goes. If you didn't see it, here it goes. Look up, please. Let me get this so I can show you the why it goes like that. So watch. If I was to take this and this one and merge them together to become this one, in order to bring the x to the middle, what happened to the inequality symbol? Able to see it? All right. Copy that, please. I know it does. And we need to get used to this because this is what we're going to be using, especially now that we're going to move into what we call functions. And you need to know how to use this for domains and ranges.
Is that even funner than this?
It's funner than this. Yay!
I'm being homeschooled. Goodbye.
All right, everybody got it? All right. Do this next one by yourself. Example 1Q. Absolute value x minus 7 less than 12. Solve, graph, and write your solution set. Copy that and go.
Well, you could put them down in the map.
All right, here we go. Here goes the process. Was there anything outside the absolute value?
No.
No. So therefore, what number is 12 steps away from 0? Negative 12 and 12. And we write this twice. X minus 7, x minus 7. However, this became a negative, therefore this is greater than. This one stays the same. Is that correct? All right. Therefore, plus 7, x greater than negative 5, plus 7, x is less than 19. So far, so good? The graph. 0, my dividing point, negative 5, my other dividing point, 19. I'm going to start with this one. Open point. What's greater than negative 5? Everything to the right. Open point for this one. What's less than 19? Everything to the left. And once again, this is an AND. Solution set all x's such that negative 5, 19, x, these are open points, therefore it's only less than and less than. Hands, have you got that by yourself? Okay, good. Let's do another one. We need some more practice. Copy this one, please. Example 1b, absolute value of x minus 3 less than negative 3. Negative 1, I'm sorry. Yeah, I just did that to see if you're paying attention. Nice. Danae, what do I do? Danae, look at me. Is there anything outside the absolute value? What's outside? So how do we get rid of it? Add 3 to each side. Thank you, Danae. So we're left with absolute value of x less than 2. Do you guys know what to do from there? Okay, finish it off, please. Go. All right, Donovan, help me to continue from here. What do I do? To graph after I get my inequalities, right? But what do I do from there? Donovan, do we have anything outside the absolute value anymore?
No.
Okay, so what do I do from there?
I do not know.
Okay, question. What number is 2 steps away from 0? What number is 2 steps away from 0? Negative 2 and 2. What's inside the absolute value? X and x. However, the negative 2 will be what? X is what? Greater than, and this one stays the same. Is there anything to solve? No. Let's graph this. 0, negative 2, 2, open point, open point. Solution set, Caesar. X such that negative 2 less than x less than 2. Hands, have you got that? That is correct. Copy this next one, please. Example 1C. Let's see how you do with that one. Bam! You see what I did there?
No, I don't. I'm blind. Thank you for rubbing in my face.
If you don't see, then you probably need to drink some orange juice like high C. No? All right.
I'm done.
Yes, Julian. Okay.
Because that carrot's getting better eyesight was actually propaganda by the British that because they didn't want to reveal that they actually had radar.
That is correct. Yes. All right, finish that, please. Copy that and finish. Go. All right, let's see. Solution set. What did you get for this one, Roberto? Solution set. X such that -3 less than or equal to X less than or equal to 3. Hands, have you got that? That is correct. All right, copy this one. Last one of these. Example 1D. We got absolute value of X plus 3. And then outside of the absolute value, we have minus 4.5, less than or equal to 7.5. Copy and solve. Let's see how you do with this one. Luke, start us off. What do I do?
Yeah, 4.5.
Bam. Add 4.5 to each side. Absolute value X plus 3, less than or equal to 12. Pass to someone. Sebastian.
After that, you equal X plus 3 greater than or equal to -4,
Uh-huh.
and X plus 3 less than or equal to +4.
Pass to someone. Christian. And you end up with?
X is greater than the negative. Oh, less than or equal to.
Less?
Greater than or equal to.
Okay. How about this one?
You subtract 3 from the side.
And we end up with?
X is less than or greater. No, less than or equal to 9.
9. Pass someone. Okay. Close it all the way. Okay.
Red circle on 9. Do the same thing to 9.
Okay. Be nice.
And then draw them. Okay, so draw -15 going right, and then 9 left.
And this is in
And
Pass someone.
figure out
Solution set. Such that
X is. Okay, hang on. I just got that.
-15
is less than, or great, less than X.
less than 9. Very close. What can tell your neighbor what that's missing, please? Equal to, because they are solid points. Thank you. Hands, have you got that by yourself? Okay, we got this, yes?
Yeah.
All right, copy this one, please. Example 2A. Example 2A. We got 3 plus absolute value X plus 2 greater than 5. Let's do this one together. Here we go. Line down the inequality symbol. Shakira, pass it to someone. Ryan, what do I do from there?
5, 3.
Close. In this case, the 3 is not multiplying.
Oh, subtract 3.
Subtract 3, subtract 3. I know this is one of those tricky ones, so careful. Absolute value x plus 2 greater than 2. Pass someone.
Here.
Chris, what do I do from there? Tell me what you write.
I'll just bring down the x. The x plus 2 is greater than 2. And then x plus 2 is less than negative 2.
Hands, have you got that? Just in it, some of you wrote it over here and the other one over here, right? Okay. Pass someone. What do I do from there?
Graphic?
Close.
Oh, yeah. Sorry. Subtraction on both sides? On both. And then x is more than negative. X is more than. Here. It's 4. Here. Here, okay. And then x is less than negative.
Thank you. Pass someone.
Right.
Brennan, help me graph this.
Negative 4. Maybe draw the circle
Open.
going to the right.
Let's see. X is less than negative 4.
Left.
Left. Okay.
And grab the
X is greater than 0.
yeah.
Which way?
Right.
What do you guys notice?
Or.
This is an OR. Therefore, solution set of X such that we start with the negative one first. X is less than negative 4, or X is greater than 0. One more of these. Copy this one. Is everybody following so far? So good? Yeah? Yeah. Where is negative 0? All right, copy this one. Example 2b. Absolute value of x plus 10 greater than or equal to 12. Copy that and see if you can do that by yourself. Go. Melanie, help me out, please. What do I do? Thank you. Absolute value of x is greater than or equal to 2. Continue. And hands if you got up to right there by yourself. Okay, good. Continue, Melanie. Help me graph it. What do I do here? Solid point because it includes it in the solution, and then this one. Solution set. Hands if you got that by yourself. Bam. That is correct. All right. So check this out. Writing utensils down really quick. Look up to the screen. Let me show you something really quick. Pay attention or you're going to miss it. Here it goes. Look up. Let's recap and see if you saw it. Talk it over with your neighbor. See what you see. Here it goes again. For those of you that didn't see it, if it went too fast, here it goes. Therefore, let's see, who can elaborate for us for this one? Priscilla. If absolute value equations are less than or equal to, these are what kind of inequalities? And if they're greater than or equal to, they are or. Hands if you saw that. Okay, we got it? All right. Last two. Copy these. Well, last two of these kind. Copy those side by side, please. We have for A, it's absolute value x plus 4 minus 5 greater than negative 8. And for B, we got absolute value x minus 2 plus 9 less than 7. Okay. Bless you. Jen, what do I do here? Add 5, absolute value x plus 4 greater than negative 3. How about here, Jen? Subtract 9, absolute value x minus 2 less than negative 2. Now, I hope now you see, from the ones that we did prior to this, that these inequalities have a negative on the other side. You guys notice that? However, look at the absolute value, the inequality sign. This one is pointing to the right, and this one's pointing to the left. So let's find out what each of these means. Look up. This says that an absolute value is greater than a negative. What comes out of an absolute value if we take an absolute value? A positive. Is a positive greater than a negative? Yes. And if I continue substituting values in here, will it always come out as a positive? Yes. Therefore, if it doesn't matter what I substitute in here, what is my solution to this without going any further? Talk it over with your neighbor, please. Wyatt. X equals all real numbers, because we can continue substituting in here any number, and it's a solution. Thank you. Now look at this one. Once again, this is a positive number, saying that it's less than a negative number. Is that true? No, it's false. And it doesn't matter what I continue substituting in here, it's always a positive. Is that correct? Therefore, is this true? Will it always be true? No. So therefore, for this one, it's no solution. Copy that, please. So far, three things that we've seen. if we have absolute value inequalities that are less than or equal to, they are and. If they're greater than, equal to, they are or. If they have a negative, if they're greater than, then it's true and it's all real numbers. But if it's less than the absolute value, then that's false and it's no solution. Does that make sense? Yes, Mr. Q, we love this. All right, good. And the last one. Example number 3. Say it. Who's going to say it? Shakira.
Pediatrician recommends that a baby's bathwater to be 95 degrees, but it is acceptable for the temperature to vary from not quite at 3 degrees. Write and solve an absolute value inequality to find the range of acceptable temperatures.
All right, so just to recap, when we did absolute value equations, remember that we wrote absolute value of x minus blank, and then it was equal to blank. And we said that here was the amount that varies. So what varies? 3 goes here. The distance or the measures go here, so this is 95. However, now it's in an inequality. So it has to be, it can't go beyond that, so it has to be less than, but could it be equal to that degree? Yes, so that's the inequality for that. So your home plate for tonight, it's play sheet 6.6. Grab one over here. Have a good one, everyone. Enjoy your home play. See you guys tomorrow. Bye.